Hi, this is Kathy Keener with Piping Solutions and TRIFLEX Pipe Stress Analysis software. And today I'm going over a training presentation on spring supports. So TRIFLEX automatically determines the load to be carried at the support location. It automatically calculates the dead weight, loads, and of course deflection and all other loads. This is an example of a spring hanger sample model. In order to get started, you would go to Setup, Modeling Defaults, and choose your spring hanger manufacturer. Now, as we have it shown here, we're showing AAA Technology, our sister company here in Houston, Texas, who manufactures spring hangers and supports. But you have several different options under spring hanger manufacturer. Then you would go to Setup, Case Definitions. The first case, or case 1, is your spring hanger sizing case. However, that spring hanger, once it's sized in case 1, is going to be seen in all of the relevant operating type cases, so that you can get a report on how it's reacting given those other cases. So your operating case, or your case 1, it can be your standard operating conditions that the system is going to see most of the time, or it can be design conditions with the design temperature and pressure, whichever you like. Other cases, like occasional loaded cases and dynamic loaded cases, need the spring hanger to be set as existing, not sizing, but as existing before you run the calculations on those. In order to model a spring hanger, you're going to open up your component dialog, whether it's an elbow or pipe or a joint, and go to the Restraints tab. On the left-hand side of that, you'll see the spring hanger support area, and you're going to check size of spring hanger right here. And the number of hangers can be 1 or 2. If you do it as 2, the load is going to be split evenly between the 2 spring hangers. The load variation here that we see is 25%. This is an allowable load variation between the operating load and the installed load, and it's specified as a maximum of 25% in MSS SP 58 standard. Now with a constant, it would be 6% or less. Hanger and support radio buttons here that you see, those are just allowing for a graphic representation of the spring hanger, either above the pipe, for instance, or below the pipe. So just a graphical representation only. No difference otherwise. Now, when you're sizing a spring hanger, so you're sizing like a variable spring hanger, for instance, and you have to consider how close that spring hanger is to an anchor. Now, you're considering it how close it is horizontally away from the anchor. Now, through lots of testing, AAA Technology, now Piping Solutions, determined quite a while back that 4 pipe diameters horizontally away or less will put all the load on the anchor. Now, if it's greater than 4 pipe diameters away horizontally, then your spring hanger can be sized properly. So what you're going to do is make the y-axis rigid on all anchors that are more than 4 pipe diameters horizontally from the proposed hangers. When the spring hangers are more than pipe diameters away from the hanger, the pipe between the hanger and the anchor is too flexible to carry all the load, rather than the anchor. So in other words, you need that flexibility of the piping to be between the two. Note that this process was developed using standard wall pipe, and the number of pipe diameters increases as the pipe wall increases. Of course, the size as well, right? So as the stiffness increases of the pipe, then the further away you need to be. Also note that 4 is the approximate multiplier based on piping system configuration and multiple trials. So here's an illustration, and this would be a hanger that would be too close horizontally to the center line of the anchor, right? Less than 4 pipe diameters away. And here is an illustration of one that would be greater than 4 pipe diameters away from the center line of the anchor. So what do? Well, you have to set your anchor as free in the Y, but only during the weight analysis that is processed during the spring hanger design. Okay, so everything happens in the background automatically, except for that you have to set free along the Y when the weight analysis is processed for spring hanger design. You don't have to do anything if it's less than 4 pipe diameters away. So there you go. You have your spring hanger sizing ready to go, and all you have to do is press the green arrow in order for it to be calculated. Okay, after you run the calculations sizing your spring hangers, you need to evaluate the results. If the restraint near the spring hanger location carries no load, that means it's lifting off. It's 0 forces and moments in the results, and that's unsatisfactory. So you have to go back and try to size things or move your spring hanger and whatever that mitigation may look like. In the spring hanger report cases, you may see out of working range, especially for an odd case like a modal frequency case, and you just would ignore that and move on. If you receive a message that says unable to size, then the load carried may be below 50 pounds. You can still size it. You just have to go to modeling defaults and select size spring hangers for all positive loads. Also, you need to check the hanger rod for angulation. You're looking at the axial movement, and you're looking at the lateral movement and the guide direction of the pipe at the point of the hanger connection. This movement can only be about a 4-degree angulation or less, as per MSSP 58. So once you run your calculations, you've gone to output, view analysis, and you're looking at your spring hanger report, you'll see this. Your data column is the node number. The next column, or your case column, is going to show which case it's referring to. Sized or existing means that S would be it was sized in case 1 always. Existing means that it's taking the spring hanger data from the case that it was sized in and treating that as an existing spring in any of the other cases. So set component status, that's going to default to existing so that you can quickly accept all of your spring hanger sizings and say save hanger status, and that will turn them into existing. That way you're ready to do some of the more complicated analysis like dynamics analysis or seismic analysis. Next column is as drawn to operating deflection. It's deflection between the spring, a hot load, and cold or installed load. Your operating load is the rigid support dead weight load. it becomes the setting where the spring will be at the start of the operating cycle. Installed load column is operating load minus spring rate times deflection. It becomes the preset load setting on the spring hanger. Spring rate column is the stiffness of the spring, called the constant amount of force needed to travel 1 inch, which is going to be equivalent to the rate equals load divided by travel. The load variation column is the MSS SP 58 and 69 allowable load variation. This is a maximum of 25%. You're looking at your cold load and your hot load. So the variation is your cold load minus your hot load divided by your hot load. Or, as put in the MSS standard, the variation is equivalent to travel times the spring rate divided by your hot load. Spring figure number, here we have a AAA T spring number. You may be used to like an Anvil 82. The spring size, total number of springs required. That's what we set when we decided to size the spring hanger, and we said we want 1 spring hanger size or 2. Then you have the minimum load and the load range of the spring, and then the maximum load. The load range used percentage is the installed minus the minimum divided by the max minus the minimum. If the hanger is sized correctly, change it to existing, and all that's required is just coming here and saying save hanger status. If there is an issue with any of the spring hangers in any of the cases, it will show up very clearly as highlighted in yellow with red lettering. Editing an existing hanger and user inputs. After your spring hanger is set to existing, you can use the hanger selection chart to plug in different spring rates and see what it does to the loads that you're trying to reduce. For instance, maybe you're trying to reduce the loads on a nozzle that goes into equipment, and the allowable for that nozzle loading is very low. You can use a different spring rate for your spring hanger. That affects the load variation of the spring hanger, so you have to make sure that it doesn't exceed 25%. For instance, if you're going from a AAA Tech E82 spring to an E268, that will cut the load variation seen by the pipe or whatever it's attached to approximately in half. A higher spring rate will produce a higher change in loads, and a lower spring rate will produce a smaller change in loads. If you have an existing spring hanger and you wish to put in different values for the installed load or the spring rate, press reset as shown below. So maybe if you're tweaking the installed load, or you're changing the spring rate to some other spring that exists, then you would press reset button. If you have an existing spring hanger and you have the data on it from the plate, then all you have to do is put in the number of spring hangers, click on the radial button to show the spring hanger in the vertical, either over or under the pipe as a support. Click existing spring rate, put in your installed load and your constant or your spring rate. Okay. In spring rate attachment Y movement, you can enter the amount of any imposed movement, like from equipment, but it's only applicable if a hanger is mounted on equipment that moves. Spring hanger is a constant. Constant spring hangers provide constant support forces for piping systems which move vertically. due to thermal expansion or contraction, and where the transfer of support load, in other words, the spring hanger load, to adjacent hangers or pipe or equipment is not acceptable. So there's certain times that you would use something like that. Because constants are generally more expensive and have a longer lead time, stress engineers typically will try to make a variable spring work before deciding on a constant. But one might use a constant when a variable hanger, spring hanger, has a load variation that exceeds 25%, or the load variation is below 10%. A variable spring hanger exceeds its travel range. So you're looking for like a movement of 2 inches or more, or 50 millimeters. Sometimes, a lot more rarely, you might use a constant next to sensitive equipment when you cannot qualify the loads on a nozzle. Okay, and in order to put a spring hanger constant in, you would take your installed load and put that in, and you would put your spring rate as 0. Okay, so that's about it. Our sister company, AAA Technology and Specialties, down the street from us, manufactures spring hangers and supports in Houston, Texas. They can be reached at info@AAAtech.com, or you can just email or call Piping Solutions, and we would be more than happy to assist you with a selection of a support or resolving an issue in your pipe stress model that involves the support. Thank you very much.